Yeah, so today I'm not going to talk about something like a particular product I do at Lose It, but I'm going to talk a lot about a skill I use in my work and that many of you probably use in your work as well, which is data visualization. And the main thing that I'd like everyone to walk away with today is not so much a particular tip or trick about how to do a cool or effective visualization, but it's the notion that data visualization is a field onto itself that can be studied and improved upon independent of whatever programming language you're using. So like I said, I'm an R programmer. Everything here was made with ggplot, which is a great package, but there's not going to be any code, just the results, just the data visualization itself. And that's to emphasize the fact that whether you're using R or Python or even Tableau or Excel, like there are things that can be done better or worse that are very platform independent. But because lots of us work with data here, let's take a look at where visualization fits into our workflow. So particularly if you're an R programmer, you may have seen this plot before, which is kind of the data science workflow. So we import our data, we tidy it up, which has a particular connotation in R. It can also just be data cleaning. And then we enter this kind of exploratory analysis loop where we're transforming, visualizing, and modeling our data until we get to the point we have some output, then we communicate it to the final stakeholders. So just by show of hands, who looks at this and recognizes, whether you've seen this image before, this is more or less what I do with different weights on different steps? A lot of people here. So if you're raising your hand right now, you are a data visualizer. So the first reason that you should care about it is because you're already doing it probably every day, and it's good to be good at the things you do every day. Not only can being good at data visualization make you more efficient in this data exploratory loop, but also to the final stakeholders. Like the previous speaker mentioned, there's nothing worse than doing all this hard work and handing it over to the final stakeholder, and it doesn't look right, or they miss the point because the visualization is not done well. So that's one reason that I think everyone here should be caring about this. Now let's take a look at kind of where we are today with data visualization and data in general. So first, we have more data than we've ever had, and we're getting more all the time. Lots of people say this, it's in a lot of talks, it's probably the basis for most, if not all, of the careers in here one way or another. This is pretty uncontroversial. So let's combine this with a couple other points. Visual displays provide the highest bandwidth channel from the computer to the human. Now, it seems kind of obvious, but we should pause and think about what it means for a minute. That means unless we jack into the matrix or get a little USB plug in our neck, or the computers wipe us out and are just talking to each other, as long as neither of those things happen, then this is still going to be the highest bandwidth channel in this important interaction loop. And so all you got to think is if you don't think either of those events are going to occur anytime during your career, then data visualization is a worthwhile investment, right? This is always going to be the highest bandwidth channel. You might be saying, oh, hey, wait a minute. We have Alexa and Google Home now. People love those things. And you watch Star Trek and they ask the computer for the answers to all their very, very complex questions. Let's try that out. Alexa, what's the weather like in Minneapolis this week? Here's the weather in Minneapolis, Minnesota for the next 7 days. Wednesday, 44 degrees and mostly sunny weather. Thursday, 43 degrees and partly sunny weather. Friday, 47 degrees and blah, 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 blah. And you get to the end, you're like, okay, wait, which day was sunny again? Because I really got to do this thing. Or you can go to Google and just get a visual display. The visual display puts not even at your fingertips, but at the dart of an eye, all of this information together for you. You can interrogate it, again, just moving your eyeballs around however you like, and it's a little interactive, so you can click on things as you're always reviewing the information in the context of other information almost effortlessly. So it's fun to talk to computers, but it's not going to supplant the fact that data visualization is the highest bandwidth channel. So how's this great field doing? Well, Stephen Few, whose books got me in to this and whose work I'll cite throughout and at the end, says in the world of data visualization, we are progressing at a snail's pace, which is pretty remarkable given the first two things I just said. Furthermore, Robert Coursera, who's another blogger, said, particularly in comparing to the field of, say, statistics, visualization as a field and community is largely invisible. Now, these quotes are for a couple years ago, and things might be making better progress now, but I think it largely still holds true. So what is this? So we have more data all the time, we have a high bandwidth channel, but we're progressing at a snail's pace, and the community is largely invisible. This is an opportunity. It's an opportunity to be better consumers and producers of data visualizations, and therefore distinguish your work from your competitors and your products from your competitors and all those other good things to keep on the leading edge of something that we agree is going to end up being really important for the foreseeable future. So why should we make data visualizations in particular? We said visual display is the highest bandwidth channel, but an Excel spreadsheet is a visual display. It's not a data visualization. So why make visualizations? Edward Tufte, and this is my last quote, I just want to familiarize you with a few of the pioneers of the field, said, effective analytic designs entail turning thinking principles into seeing principles. So how does that work? So you have thinking principles. You want to find patterns and trends and outliers. Which of these things is bigger? Which of these things is not like the other? So we take something like that. So I would say that we visualize data to leverage our visual system to detect patterns. Guess what our visual system is very good at doing? Or exceptions to patterns, especially unexpected ones. This is why we make a data visualization instead of a spreadsheet. So if you look at the data I showed at the beginning, it starts with a spreadsheet, something like this. It's very accurate. You have the names of every individual star or around which these exoplanets orbit. You have their radius and mass down to several decimal places. It's very accurate, but it's very hard to detect patterns this way. The best you could hope for is resorting by one or another column and getting the extreme outliers. That's no good. But you take all this data and put it into a visualization. It's a little less accurate. There's a trade-off. People are, obsessed with then annotating everything back onto this that was just taken out of the table. But the power here is that instantly you're inspecting many, many data points. Everyone here, whether you're an astrophysicist or not, can see there's a clear trend. Trend changes for some reason, and there's some variance and some outliers. So that's why we make data visualizations instead of using any old displays to leverage our visual system. And this brings us to one important aspect of data visualization. Just like not every visual display is a data visualization, not all data needs to be visualized in a graph or a pattern, which might be something kind of odd for me to say at this talk, but I can demonstrate it to you with a quick example. And this is audience participation time. So what number do you think is represented by this donut chart? And I'll give you a hint, it's somewhere between 1 and 100. So anybody just shout it out. What number do you think this is?
66.
66, like anything else? 73? 70, okay. So, lots of smart people in the room, a little bit of disagreement. Next question, anyone can answer this one too. What number is represented here?
72%.
Anyone want to take a different number? Any dissenters? Amazing. Room full of people, no dissenters whatsoever. So here's a question. What's going on here? We've seen these things probably a lot. And I'm going to say, at Lose It, we use these things in our user interface. And there may be user interface reasons for wanting to do this. We're selling a product. Appearances matter. People like circles. People like having the circle like complete and close. That's a big thing for us. And so there are reasons, we're trying to sell a product here, right? But in terms of data visualization, let's say you're making an internal dashboard for, hard-nosed executives. They're really busy. They're only going to look at this, if it's effective, if it saves some time. And of course, they want all kinds of metrics on there. So space is at a premium. You got to ask yourself, why am I using 9 or 10 times the amount of space to show what a number would be? And you can say, oh, well, I'm going to loop in other bars around this one. But as I'll show later, that's probably not your best bet either. So you always want to be asking, first of all, whether a visualization is necessary and effective, whether you're turning seeing principles or in thinking principles into seeing principles. And another reason that data visualization is very important is visualizations can fundamentally surprise us. So this is something called Anscombe's quartet that was developed in 1973 by this guy Anscombe. And what he did is he found these 4 sets of data points that all have to within the specifications up here. I know it's a little small, but the linear fit, the x mean, y mean, x and y standard deviations and correlation, all identical to a few decimal places. It's x standard deviation actually to many decimal places. And yet by plotting these, we can instantly see that they're very different and that probably most of them should not be fit with a linear trend. Okay, and this is something, so not to say that statistics and machine learning should be used. Of course they should be. Eventually we're gonna get so many variables that you can't visualize them all. But the point is, this is important in that kind of loop where you're, transforming, modeling, and then looking, because eventually you're gonna see something like, oh, now I see why it's wrong, right? Instantly with a data visualization. And actually, okay, I'm gonna try this. I'm really nervous because I'm gonna have to get out of the PowerPoint. Actually, you know what? I'll just say Google data source doesn't after this talk, okay? Or I'll show it at the very end after my last slide. I promise I'll show it. It's really cool. It is a modern update of this with computers where they have a dozen different patterns and they're permuting between the patterns. So I'll show it at the end. I just don't want to throw off the flow of the talk now that everyone's been so patient. So promise that for later. So I've gotten this far without really defining what visualizations are. I'm not going to give a real like precise dictionary definition, but I'm going to characterize what I think is their most fundamental quality, which is that visualizations are mappings that are encoded and decoded. They're encoded with software and they're decoded by humans. And that whole decoding by humans part is why I'm emphasizing all this stuff about, you know, what we can see with our eyes and visualization and why it's important in the loop. Okay, so here's the mapping I used to generate that astrophysical data on the title slide, right? Radius goes to X, mass goes to Y, discovery method goes to color, more precisely hue, which is the kind of color where you say this is blue and this is red and this is green, right? That works really well. So how do these mappings work in general? We have types of data and types of attributes. So the two fundamental types of data are quantitative, mass, radius, distance from Earth, and categorical or qualitative. Discovery method, is this a single star or a binary star? How does it work? Then we have these visual attributes, such as length, width, orientation, hue, and intensity. And so all we're doing this whole time is just creating better or worse mappings between these things. Now, there's a few that are not valid. For example, if you're looking for quantitative data on an interval scale, you double it, you get twice as much, then things like shape are probably not going to work. Shape has no natural ordering. You can't map quantitative data to shape like you can categorical data. Okay, but in general, many of these mappings are valid and that they work. If you put them into ggplot or something, it'll say, okay, here's your plot. But not all mappings that are valid are equally useful. And that's very easy to demonstrate. And by the way, this whole mapping thing, if you're an R programmer, if you use ggplot, this is very natural for you because of the aesthetics argument in ggplot. That's all this is. The aesthetics argument is where you create all your mappings. But I said this was not, this is a code agnostic talk, so that's the last I'll say about it. But it's almost trivial to create a much less useful mapping here. So we map mass to X, radius to size, and discovery method to shape. Again, they're all valid. The categorical variable is mapped to something that can take it, but this is pretty useless. And I don't think anyone would ever really make this, but other things like this can happen and do happen. So what's really going on here is that some quantitative encodings are easier to decode than others. And there's a rough ranking of the elementary perceptual tasks done, I believe, in the 70s by Cleveland and McGill, basically figuring out how easy is it for people to visually perceive these different things. And the winners come out on top are position along common scale, position along non-aligned scales, and length. So these linear distances and relative positions, right? And that's why we have bar plots, we have scatter plots, we have line plots, all mapping things on their axes to the two spatial coordinates, right? And so these are, you know, if you're doing visualization, you should always try to use these things first because they're simply the most effective. And also notice that, you know, if you have a bar plot or something, you can use categorical variables with position as well, right? And I want to talk a little bit more. For the rest of the talk, I kind of want to talk about some examples of using position, and then when we go to categorical variables, I'll talk about color. Okay, and I'm just going to show some examples now. So let's talk about common versus non-common scales. Say someone says, hey, can you show me, I'm interested in the GDP of the North American countries over time. I might show you something like this, okay? Now this is technically an answer to your question. All the information is there, right? But what can you really tell from this? You can tell that USA has a lion's share, which I'm pretty sure I knew before. You can tell that it's been going up pretty much all the time since the 60s. I'm pretty sure I knew that before too. And it looks like something very sudden and bad happened just before 2010, when I'm pretty sure I knew that too. Okay, when you start asking more questions, in particular questions about Canada and Mexico, it's hard to tell what's going on here because everything in Canada and Mexico is influenced by what the USA is doing, and everything that Canada is doing is also influenced by Mexico. So it's hard to answer questions like, you know, was Canada looks like might be ahead of Mexico, but was it always? We're almost not even doing a distance measurement. We're almost looking at the width now, which is farther down that perceptual list. This is a difficult task to do. Solution is pretty simple. Move to lines. So we can instantly see that the United States was responsible for almost all of that upward trend on the scale, at least. And something is going down on, there's some sort of mixing down there and potential crossover between Canada and Mexico, but it's hard to see now, at least when we had the areas, you know, everything was separated. We have lines now and they're crossing. And so this is a good lesson. you can't always solve everything with one plot, especially when the orders of magnitude vary wildly. So let's just take out the United States, and I want you to watch when I put this next slide. What's the first thing you notice? Where are your eyes drawn when you see this next graph? If you're like me, one of the first things to know about this graph is where the lines collide, right? Where they intersect, which is meaningful on this, which shows that briefly Canada was behind Mexico. All right. And you can also see, these common mode things. Clearly something, happened with the recession and then up and down. So you can take apart the commonalities and the differences, which was virtually impossible just 2 slides ago, right? I mean, can you even see it now? Look, it's just 2001 or 2002 where Mexico briefly overtook Canada. I can't tell. So one final thing here is, what if you're chiefly interested, this is good if you're interested in overall how Canada and Mexico are doing, how they're doing relative to each other, but what if you're focused on the difference, that's all you care about? Then we're back to the non-aligned scales, non-aligned measurement problem, right? Because you're basically trying to subtract Canada from Mexico and Mexico's line is moving. So solution's simple again, just subtract them and plot the difference. So this is another thing to do, is always plot the variable of interest, right? If you're interested in the difference, just plot the difference, because you're going to see things that might have been hard to see otherwise. And then one final note on position, or one final note for now, position is the gift that keeps on giving. And so there's this famous diamond data set coming out of the ggplot package. And here I have, using only position, I've mapped 4 variables, 2 categorical, 2 quantitative, right? And so this is showing the various pricing and carat value of these diamonds by their clarity and their cut. Okay, so there's a lot that's being done here. This is a lot of data only using the position variable. Remember, we have all those other variables I showed before we haven't even touched on yet. So position, I think, I hope convinced you, should be your go-to variable when making data visualizations. So I'm going to move a little bit on to color. Okay, anyone here into cryptocurrencies and Bitcoin at all? It's okay. So what is the abbreviation for Bitcoin? It's ticker symbol, BTC, right? Okay, so we're going to try to find some Bitcoin. Okay, so I want you to try to count how many times the sequence BTC shows up in this next graph, this next chart. Okay, so you're looking at this, you're probably going, okay, that's no, 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 1, no, 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 no more in the first line, no, no. And so basically the only way to do this is serially, right? Now, if we add the preattentive attribute of color, you see them instantly. And it's preattentive in that it's not only effortless, it's automatic. It's almost impossible to suppress the location of the BTCs now, right? If you wanted to be like, can't see them, you can't stop it. It's happening automatically in your brain, right? So this was basically what makes this another thing that's kind of obvious, but it's what makes color so powerful. But there's a catch, which is that you can oversaturate color space, right? So I put, these are called distractors, right? So I make all these things colorful again. You can probably still tell where the BTCs are, especially once you realize they're all red, but it's not popping. It's not effortless and automatic in the same way it was in the previous example, and especially because of the closeness of color of orange and purple to red, right? Same thing is true of charts. So you see this, where are the squares? Well, I can make them all red, and now they pop a little more. But then I make everything a color, and they disappear again. So this is a powerful argument against kind of the overuse of color and the frivolousness of color in data visualization. And so I want to use this in kind of my final series of examples here on how to take a visualization that's not doing too great and turn it into something that's much more effective. So here's this example that we're going to use. And this is the percent unemployed in the 10 most populous cities in the United States in 2013, which just happened to be the latest data available in the data set that I grabbed. And this is a disaster. But you may have seen something like this before. Maybe you even made something like this before. It's okay. We're all learning, right? But this is extremely ineffective. All right. This color, we've put together all of the labels at the bottom, illegible. You think the color can save you, but now you're looking back and forth between, okay, green, what's that green? Not the one, but the other one. I guess it's Los Angeles. Okay, wait, now what I'm looking at, this is very ineffective. Oh, I have a low battery. It's okay. We'll make it. Can I? Thank you. And you'll notice even if I take away the terrible labels, you're still in a bad position. And a couple things going on here. One is that there's just the main thing going on here is there's just too much color. You can only hold about 4 or 5 things in your mind at once before you need to go back to the well of the legend to find out what's going on, right? And so this is just too much, and it's not doing anything, and it wasn't position working anyway. What always amazes me how in almost all software, the default is for bar charts to be vertical. When just turn them on their side, you get the exact same thing, and there's almost no chance that the titles are going to collide, right? So put your bar graphs on their side, and then we can take away that color. And now we have kind of this bland looking thing, but it's easier to look at, and we're able to just scan up and down and see things. Now, I told you position is the gift that keeps on giving. So these are in alphabetical order, kind of reverse alphabetical order because of the way R flips its axes. But what we can do is we can just reorder them by magnitude, right? So now we kind of use position to also, again, encode this pattern. You can kind of see, oh, look, that's interesting. The 3 at the bottom all kind of seem to be tightly packed together. You might notice something about those that we can highlight now that we've freed up all of our color space, which is that all those are in Texas, right? Again, now we're doing pattern recognition. You're seeing things, right? And we can go further, right? It's not the only state that's represented multiple times here. Looks like California not doing as great on unemployment as Texas is, okay? So now we're really getting somewhere. And I think duplicate slide in here, but okay. But one more thing, because I told you we can still keep putting more and more stuff into position. We don't have to even use color. We're kind of competitive in Boston, right? Let's see how Boston's doing. Let's drop a reference line in. Note to your readers, reference line is Boston. And now we have something that we can kind of draw conclusions from, right? So we've gone from this kind of garish and ineffective display to this much more effective one, just using kind of some judicious uses of visual principles and kind of the basics of design, okay? And so these are the kind of things that I think, we're all to learn a little bit more about, would just, fill the world with better visualizations than a lot of the ones that we see now. So I hope now when you look at a visualization like this, you kind of see all the small decisions that go into making it effective. And I didn't cover every single one of these. So a few things about having nice notes and minimizing your non-data pixels, about having, these are just dark enough to be useful as reference lines, but they're not visually dominating the graph. And so, yeah, there's a lot that goes into these things, but it can be learned. And I've referenced some people along the way here, and I've just put up, I would highly recommend these books kind of almost in this order. So Stephen Few, who's written many books on the topic, has a very great general introduction to modern data visualization. Let's start there. There's another, to highlight another author, Naomi Robbins, has a great kind of desk reference that I highly recommend. And if you really want to get into some of this stuff and talk about color spaces and perceptual tasks and stuff like that, I recommend Information Visualization and Perception for Design by Colin Ware, because that person I quoted saying that this is the highest bandwidth channel that there is. So that's my talk. I'm happy to answer more questions. Thank you for your patience during the technical difficulties.
So we think about data visualization really don't, like you said, why it's moving at snail's pace and the community.
Yeah, so I can just offer some of my opinions on that. I think that in terms of why the community is invisible, it's kind of weird. Data visualization is hard to be that is your only job, right? You're usually embedded somewhere else, like you're a statistician, you're a data scientist, you're someone else who uses visualizations. So I think that makes it a little harder for visualizers to kind of represent themselves because it's not like in a totally encapsulating profession, except for a very few lucky people who get to just do it as basically their only job. So I think that's part of it. In terms of why it's moving at a snail's pace, Stephen Few is very critical of lots of the kind of junk or pop research being done, in this field right now. I think is what he's getting at there, is that because a lot of people undervalue it, and then it gets popular, and then lots of people kind of try to do some pop version of it. He sees this as kind of really impeding the field relative to its importance. So Stephen Few has a very active blog, so I definitely recommend checking out his blog for his deeper thoughts on why we're moving at a snail's pace, and on Eager Eyes as well, the other blog. I think that they'll have much more detailed insights into the community than I can offer right now. But thanks for your question.
any tips for how to approach visualizing time series?
Yeah, I mean, it depends kind of
Or like
entirely.
any reference, or because it wasn't in any of your slides, I was just curious, like, do you have any?
Yeah, so it kind of depends on your use case. I'd say obviously, your time series, you're usually making line plots, and so all the things I said about using position, relative position effectively. Also, if you pick up some of these books, I've seen some cool things where you're able to kind of layer in kind of mini cycles of things. You have like a like a Monday, Tuesday, Wednesday, Thursday, Friday. Then in each one of those, you have a small line, which is like the pattern, throughout the year. Like here's how Monday does all year on the Monday. And so then you end up with kind of like, you're able to see the weekly trend, and embedded in the weekly trend is the yearly trend, right? And so maybe later I can like try to pull up an example of that. But there are some specific tips about time series, and Stephen Few in particular does a very good job of kind of the taxonomy of data visualization, and say like, here's what to do for this, here's what to do for this, here's what to do for this. So I'd highly recommend taking a look at that book.
Yeah, the big risk in time series, or big problem, is that something called aliasing, whereas the rate of data capture differs from the actual pattern itself. And so that's where you want to make your viz around the actual pattern, not always the data collection. The classic case, I've been working with some data right now in time series. They collect it every day, but the real pattern is at the week. So you can get a daily plot, and it looks like a mess. But once we transformed it into a weekly plot, you saw that Monday through Saturday, Monday through Saturday, Monday through Saturday. You begin to see the cycle. So that's one of the things you want to look at with time series, particularly. Where is the information in the data? What cycle is that?
Yeah, I can't find a good pop-up really quickly, but I can search for that, and I can send you a reference too. I did promise, now that we're past technical difficulties, the data source dozen. Check this out. Those points are maintaining that level of precision even while they're moving between the different patterns. Sorry. So any other questions while we're watching that?
So is there any times where you use just simple tables as a data visualization, like if you want to use them in a dashboard kind of thing?
Yeah, I would say that the first thing that comes to mind is sometimes you'll see the tables that are additionally have the kind of heat map component, so you'll have the numbers, but then they'll be kind of heat mapped, maybe or hot or cold, maybe a little bit of blue and red as to which values are extreme, right? So that's something that's an example. Or are you talking more like just an unadorned table, just the table?
So like the way you do it in Excel, there are rows and there are columns. So like for example, Power BI allows you to put values into a table. So is there a situation where you can just show the table right itself, not visualize the part?
Yeah, I mean, it goes back to what you're trying to show, right? Like if the table shows the most important information, there's nothing to be revealed by visualizing it, then go for it, right? And in fact, I'm going to plug him one more time. Stephen Few's book, he has a whole section just on tables, which is like crazy to me. Like that is a substantial, because there's lots of books on graphs, but part of his book is just on the effective, design of tables. So that's totally legitimate. This goes back to like what you're trying to accomplish. And oftentimes with dashboards, there's some sort of pattern recognition going on to where everyone's looking at spreadsheets all day and they check the dashboard, right, for kind of the big pattern overview. But if it fits the scenario, you can definitely do it.
And a good package for that is kind of new, the GT package is like grammar of tables. For people like that.
Is there special cases where using shapes may be better than using colors? Because I've never had many examples where I actually found shapes to be better.
Yeah, I think I think the first thing is that because color is so much more effective, and if you're just trying to encode one categorical variable on like a scatter plot, you're going to use color. Now you can get to situations where maybe you want two categorical variables, right? So now you can't do color twice. You want to do color and shape on a scatter plot. Then you just got to be careful, because one thing that color and position do very well is they're highly separable, which means it's very easy to look at something and say stuff's on the left or the right, and stuff is blue or red. But when you start mixing things like shape and color, it becomes harder task to say, like, find all the red squares but not the blue squares, or find all the red diamonds but not the green circles. And so you have to start thinking about what you're trying to emphasize when you start using shape. But yeah, or also you have to worry about I guess also back when people used paper more often, and you didn't always have access to color paper, sometimes you could double encode things so that the printer ran out of ink and you're just doing black and white handouts, your thing still makes sense, right? So that's another thing. It's robust against those kind of issues. It's robust against the various forms of color blindness, obviously. So which that is something that I would like to learn more about too, is the theory behind color blindness and how to develop general purpose palettes like that. Oh, sorry.
But I just want to comment on your last comment, that this question, color blindness specifically, is a situation that I had to deal with. Not
Yes.
for person, but for stakeholders.
Yes, and that's actually one of the last things I'll think about this talk is, like, I really wish I had time to do some more research and address color blindness, just because.
There are various color palettes specifically for different ones.
Yeah, there are tools that help to find colors.
Yeah, if anyone has any resources on that, I'd be, like links or software packages, that'd be really cool. What's it called?
I don't know.
Okay. All right.
I think it's color blindness as well.
Okay. That's great.
Brewer color.
Brewer? Okay. Great.
Usually, when I do visualization, I have to do something. That's why I have a report. And what I want to say is I have a big pile of data, and however you look at this picture, you'll see my point.
Mm-hmm.
Right? The point is the center. Right? This graph is supposed to be argument, suggesting a position. Thing to do, the way you interpret this data, meaning that it's not some property that came out of the data, it's a property that came out how we look at it. So whenever I focus on the visualization, what I'm trying to do is convince somebody looking at it that it means something.
That's an important point, is that, going back to that workflow graph I showed at the beginning, is that, there are different use cases, right? So in exploratory data analysis, we're not trying to convince anyone of anything because we haven't even found the point ourselves, right? And so there we're just trying to get, make that loop really effective. Now, when you're, communicating, and again, sometimes you're communicating, you try to do it from a neutral point of view. Sometimes you try to do it, like you say, to make a point or convince someone of something. That's when doing things like using color sparingly and stuff like that is really effective, because you can highlight things much more effectively and have them not miss the point if you stick to some of these principles. But yeah, there are different contexts in which we want to do visualization, and that can lead to different ideas or compromises about what the most effective thing to do at that time is. That's why it's just good to have a broad view of all these different things, so that whatever your particular situation is, you can apply them in the most effective way.
Robert?
I also wanted to know, what do you recommend for networks that they become hairballs?
Sorry, can you say it again?
What do you recommend for visualizing networks that they become hairballs?
Oh, networks. Yeah, that is something I don't actually have a recommendation off the top of my head for, other than the rules of perception are not going to change, right? So you're, coloring nodes or, things like that, those things won't change. You might also try, so sometimes when we overplot, the problem of overplotting like scatter plots is to make things more less opaque, to change the alpha level of the color, or that's a possibility. Yeah, but I'm sure if you dive into some of these resources, there'll be something, it'll lead you down like an internet trail. There might be something there. I'm going to actually look into that. That's an interesting question. Thank you.
What do you think of the strategy of trying to, I think this is why Edward talked about kind of maximize data to ink ratio.
Yeah.
Data draw, in terms of everything that is
yeah, I think, whoops, don't look at that. It's an earlier version of the talk. Under here. Yeah, so I mentioned that a little bit, and so it can be effective. So I've tried to do that here, right? Minimize non-data ink pixels, kind of make these just light enough, to see. Now you might want to take more away from this. You can say like, oh, why are there axes and stuff like that? But then you get into like defining the space that separates the graph from the rest of whatever you're doing. And so there is a trade-off, and I think because of Tuffy's influence, things are a lot cleaner now. When I'm remembering reading his books, he went pretty extreme to the point where his bar graphs were like lines with little like almost like street lamps, right? Because like this is all you need. Everything else is a waste of space. And so that could be maybe a little extreme or idiosyncratic. I don't think you're gonna see that a lot, but definitely the overall trend, to minimizing or maximizing the data to ink ratio, or minimizing the non-data ink or pixels. That's definitely been influential. I just think that Tuffy might have taken it a little extreme.
Just a comment, completely off topic. I work at Aetna PDS, and we are hiring like crazy. If any of you guys are interested, please come up.
Thank you.